Welcome to our senior design presentation. We are group number 5, we are Ford group number 2, and our topic is Nylon 12 SLS material testing. My name is Doug Daniel and I'll start us off. So I'm sure that most, if not all of you, know a little bit about Ford Motor Company and what they do. They were founded in 1903, they're the fourth largest auto manufacturer in the world, and they are headquartered in Dearborn, Michigan. They were the first to implement the assembly line, and they continue to push innovation in the manufacturing, and this can be shown best in their new Advanced Manufacturing Center. It is located in Redford, Michigan, just 10 miles away. It was opened December 4th, 2018, and is a $45 million facility. They are betting that their futuristic technologies will continue to help them innovate and push the manufacturing envelope. They use virtual reality, augmented reality, and 23 3D printers to produce prototypes and some production parts. Another name for 3D printing is additive manufacturing. Additive manufacturing creates 3D parts by adding materials layer by layer. The additive manufacturing market grew to over $10.4 billion in 2019 with an annual average growth of 25%. The reason for this growth can be attributed to the diversity of industries and products that can take advantage of it. At Ford's Advanced Manufacturing Center alone, materials from sand, carbon, and metal are all used. Some of the most common forms of additive manufacturing are fused deposition modeling, material jetting, and powder bed fusion. In fusion deposition modeling, FDM for short, filament material is drawn through a nozzle and then heated, extruded, and deposited onto the build platform layer by layer. In material jetting, liquid droplets of photosensitive polymer are dispensed from multiple print heads. The polymer is then exposed to UV light, which causes it to harden, building the part. Powder bed fusion has multiple subsets, including selective laser sintering, selective laser melting, electronic beam melting, and selective heat sintering. Our project focuses on powder bed fusion, and more specifically, selective laser sintering, or SLS for short. At Ford's Manufacturing Center, a Nylon 12 polymer is used in their EOS SLS machines. This machine uses lasers to sinter together thin layers of powder, repeating the process over and over, with new layers of powders until the part is complete. The parts that Ford makes with their SLS machine are prototypes and can be created much faster and cheaper when compared to more traditional tooling techniques.
My name's Hayyan, and I'll be going over some of the current situations that are at Ford with this project and a little bit of background on Nylon 12 itself. So our team took a visit down to the Advanced Manufacturing Center a few months ago, and we got to see some of the problems firsthand. We saw what materials were being used, how it was being tested, and we saw that the procedure was not efficient at all. We saw that there was no quality control processes for the powder or the parts. They were conducting a tensile and a melt flow test. However, there was no significant data collected from these tests, and they lacked standardization. And really, there was no conclusions that were being drawn from these tests. Our goal is to standardize this process from start to finish and improve the testing and analysis part of the procedure for the Nylon 12. We plan to have an efficient test that gives reliable data, which can ensure the quality for the powder and the part. We are going to prove this through testing and through testing the research we have conducted, and this will be conducted at Central Michigan University. So, like we mentioned, the powder that we are using is Nylon PA12, and we can see some of the mechanical and the thermal and the physical properties listed on the right side, and we can also see the chemical structure on the bottom of this PowerPoint. So Nylon 12 is a petroleum-based product. It is a polymer, and it's currently petroleum-based. However, the lead suppliers are trying to derive the feedstock from renewable resources currently, but as of right now, it's a petroleum-based product. It's a great polymer that is very rigid. It has chemical resistance. It's a strong and durable polymer. It is also biocompatible, and it's certified for contact with foods as well. The powder is roughly about $100 per kilogram, and Ford tries to reduce this cost by mixing it with reused powder, so that we have a 50-50 blend of reused and virgin powder. The reused powder comes from the old builds, and the powder that is unsintered and left on the top, that powder is brushed off and used to blend with the virgin powder. This reused powder can sometimes be thermally damaged as the 3D printing process goes to really high temperatures. So some of it can be thermally damaged, and really what we're trying to do with our project is to make sure that we have some sort of quality control procedure to make sure that the powder, the 50-50 blend, is of optimal quality.
Hi, I'm Natalie Cavaretta, and I'm going to be going over the current test methods that Ford uses. So the first test that Ford AMC is conducting is the widely used tensile test. This machine pulls a specimen to its breaking point in order to gather information on stress, strain, modulus of elasticity, and ultimate tensile strength. These values are used to determine if the material has been thermally degraded, or in simple terms, if the material is good or bad. Ford uses the ASTM standard for tensile testing to ensure that each employee is conducting the test the exact same way. This standard lists the procedure, preparation, and calculations needed to perform this test. Based on our research and in-depth conversations with our Ford contact, it has been determined that the tensile test is creating repeatable data and meeting all the needs of the team. Although the machine itself is good, our group plans to improve the process by creating more focused lens for data collection by investigating what data should be measured and why it is important to analyze that specific quantity. The second test performed by Ford AMC is the melt flow test, and this is our main area of concern. This method uses a heated barrel to melt the specimen into a viscous fluid, and then the material is forced out by a piston. The data collected determines viscosity, and analysis of that determines if thermal degradation has occurred. This test method is more complex than the tensile test, so Ford AMC relies heavily on the ASTM melt flow standard to ensure that test conditions, procedure, and calculations are all performed correctly. However, due to the nature of the melt flow test, there is major variability between users, and even between trials of the same powder batch. Not only does the melt flow test create inaccurate data, but it is also very inefficient. Our Ford contact said it takes 3 times longer to clean the machine than to simply conduct the test itself. Ford wants efficient and reliable data, and the current process for melt flow testing cannot do either. Therefore, our group has set out to find a solution to this problem.
Hello, my name is Peter. So since the Nylon 12 powder is exposed to being thermally degraded, we find it most important to conduct a thermal analysis on the 50-50 Nylon 12 powder. This will be used to ensure quality control on the product in the most efficient way by identifying physical properties of the material, which will identify any degradation. A prevalent thermal analysis technique is the differential scanning calorimeter. The DSC measures thermal events such as glass transition, melting, crystallization, Curie reactions, onset of oxidation, and heats of transitions, or enthalpy. The DSC heat flow can be used to determine reaction kinetics, specifically heat capacity, compatibility and stability of blends and alloys, effects of aging, and impact of additives on crystallization. In short, the DSC is a tool to complete a full thermal analysis, and we will be using the ISO 11357 standard. So here is the heat flow chart, which is like a material's fingerprint. So it's very specific to the material and can help identify many different physical properties such as degradation. For the Nylon 12, it is an endothermic process. So we'll be looking at this left graph over here. So the first part to note is the glass transition, where the material will start to degrade. And then on the far right, circled over here, you have the melting curve. The sample heat flow is measured by area thermocouples using the thermal equivalent of Ohm's law. A material's response in the DSC can be determined by equation 1, where the first part of the equation of CP will express specific heat capacity and change in heat capacity.
This will be very important characteristics to identify things such as denature and decomposition, which will allow us to ensure quality of the material. We believe this testing method will be the most beneficial for the Nylon 12 powder. It is a short run test with very little cleaning and is very consistent. This will be a great way for effectively and efficiently ensuring quality control on the product. To continue off that, the cost is very similar to the melt flow test and is less than the tensile test.
Hi, so I'm Mitchell Kent, and I'll be discussing our data collection methods and development of a threshold for material quality. So it's essential for us to determine a threshold for material quality based solely for quality control purposes, and the data that is collected needs to be useful to Ford. Currently, they're not collecting the data that they're gathering from their tests. They're not storing it anywhere, and it's not providing very much meaning for them in their testing regimen. So finding a suitable quantity that they'll be able to store and reference in the future, and developing a threshold from that. And the way we'll be doing this is we'll be ordering 3 sets of dog bones, 15 in each set. There'll be 3 batches. And those dog bones will be tested using the Instron machine following the ASTM standard for standard test method for tensile properties of plastics. And from those same 3 batches, we'll be getting powder, 50-50 mix of virgin and used powder to test in the DSC machine. And we'll be following the ISO standard for DSC's testing of plastics. From these tests, we'll be gathering mechanical and thermal data that will be used to create a statistical distribution and develop a threshold for a quality material and product. Next, I'm going to discuss our ideas to deal with the melt flow indexer. What we're going with right now is abandoning the melt flow completely, mostly because it takes too long to clean and there's only one relevant value obtained, which is the viscosity of the Nylon 12 material. And the goal is to implement DSC testing or a different test method. We also discussed potentially modifying the current machine Ford uses to accept powder Nylon 12 because the machine is designed to take pellets. We haven't had too much research show up on whether we can modify the machine or if there's a current machine out there that is compatible with powder. And our last idea was to find out a more effective cleaning procedure. There's been some research into solvents to dissolve Nylon 12 to easier clean the machine, but these solvents are acids that can be potentially corrosive to the machine elements. And Ford currently uses just a rag to clean the machine, and there's been research to show that that is mostly the most effective way to clean the melt flow machine. So instead of going with these other 2 options, we're going to decide to abandon the melt flow and pursue other methods of testing.
My name is Maggie Somerville, and I will be going over some of the past, present, and future work that our team has been doing in the past few months in order to complete our project. So currently our team is ordering testing materials from Ford. So over here on the side I have the bill of materials that our team has put together. So we'll be running tests in 3 batches. So for the tensile test, we will be using dog bones that are provided from Ford. All of these materials are at no cost to our team, and they are just being provided. So the dog bones, we will have 15 pieces each in each batch. So that will be 3 batches of 5 dog bones from each axis, all of the axes, X, Y, and Z. And then for the DSC test, we will be using 50-50 powder, since that is what Ford uses currently. So we'll be using the 50/50 powder, and we've requested 100 grams of that powder for each of our 3 batches. And then separately, we've ordered 40 grams of virgin powder and 40 grams of recycled powder. And these materials will be used as baselines and thresholds in order to compare our thermally degraded powder with the virgin and recycled powder. So since Ford is going to keep their tensile test, we recommend that they keep it. It is a beneficial test for the testing of the polymer, and it is also low cost. So we're going to be running tensile tests on CMU's campus in order to compare our values with Ford's values and make sure we know what we're testing, what parameters we're testing, and make sure our numbers are cohesive with theirs. And then for the DSC test, we will, like I said, we'll be using 3 batches of 50/50 powder. And then testing this material will bring real values that we can integrate into our research. And depending on how our DSC test fits Ford's needs, we are willing and ready to discuss a new testing method that may need to be explored next semester. So to go into a little bit more detail about the differential scanning calorimeter, or DSC machine, it is a TA Instruments machine, and we have one on CMU's campus. And so this machine was actually a new idea that our team researched, and it's something that we think would be a very good alternative for Ford to use instead of the melt flow machine. So after doing research and getting our background information, we actually received a demonstration from a CMU grad student on the DSC machine, and we did this last week. And so we found that it is a much quicker and more efficient test than the melt flow, and it doesn't need nearly as much cleaning or time setting up or things like this. So we will be running practice tests starting next week with sample powder provided from our advisor. And so these practice tests will help us understand how to use the machine and how to use the software and get the time down and how long it will take and all these sorts of things. And then looking ahead into the spring semester, we'll be able to get right into testing the DSC and tensile tests with Ford's material. Since we'll already have these practice runs under our belt, we'll be able to just jump right into it. And then after we run these tests, we will analyze the results from our tests, and we'll start to determine a baseline and a threshold for testing. And then going along with that, we might also be looking into additional testing methods if we find that the DSC machine isn't meeting the standards that Ford needs to do quality control testing on their powder. So we might be looking into rheometer or spectrometer, and both of these machines are also available on CMU's campus that we could look into and look into those and work on those as well. And then finally, we'll be preparing and presenting our final proposal to improve the SLS process for Ford Motor Company. And then this next slide, we've just included a few key references in case anyone would like to look into our research. These 3 references are websites that we've used time and time again during our research and during our writing of our proposal. Thank you everyone for coming, and thank you for your time and attention this morning. Do we have any questions?